Hi guys, good morning. Welcome to math. Nice to see everybody logged in and on time today. I guess I started on time, so you guys are here on time. That's good. If we could begin with some green check marks, please. And if you ran into any problems, I asked you guys to finish the first 3 pages of the learning guide. If you ran into any problems on those first 3 pages, you wanted me to go through them with you, I would be happy to do that as well. If there's no pressing issues or questions, I am just going to continue on and plug in through this learning guide. It's just more of the same today, essentially. Still talking about ratios, rates, and proportions, but we do get into a few, I guess they're maybe kind of like word problems. They're not, well, yeah, they're word problems involving ratios, rates, and proportions. So if you do have any issues and want to do 15 for sure, I can do 15. Look, it's up right behind me. Yeah, definitely do 15 costs in. Anything else that we ran into? If we get some green checks in chat, just so I'm not talking to myself. I know Costin was writing, but Emery Josh, thanks for your green check marks. If we can get everybody else to give me some green checks, I'll just make sure everybody's on the same page and audio's working and the live stream's working. If not everybody gives me a check mark, I get worried. There we go. Much better. Thanks, guys and gals. Anthony, Brianna, Jonah? Is that Jonah? I can't see from here. Bright lights. I think Jonah's still lingering from last class. All right. We'll just plug away here. So number 15 here at the bottom of page 3, this is the learning guide from unit are we in? Unit 1. There you go. It asks us, calculate the amount of oil required in milliliters to make the following mixture. Okay, we can do that. And a mixture of 41 using 20 liters of gas. So I'm just going to scroll up, and we did a question similar to this where we had our friend Mike, and he was owner-operator of a landscaping business. He had a gas situation where he had to mix 50 to 1, and he had 5 liters of gas. So we used the strategy we called cross-multiplication once we had everything set up. So this question, number 15, is almost identical to number 13. You have your ratio, 50 parts gas to 1 part oil, and then you have volume of gas. In the question 15 or 13, it was 5 liters. This question down below is a little bit different. So because we have these ratios, we can write them as fractions. So instead of 32 over 1, I'm going to write it as 32 gas. I don't have to write in gas, but I will, over 1 oil. So 32 parts gas to 1 part oil. I'm going to make this equal to, and in this case, I have 8 liters of gas over some amount of oil. I don't know what. It says calculate the amount of oil in milliliters. Now, before I even begin, I see that my gas is in liters, so my answer is going to be in liters, so I'll have to convert it to milliliters, which just means dividing by 1,000, but we'll see how we do. So when I write down these ratios, I write them as a fraction. I want to make sure I have gas on the top on both sides and oil on the bottom, or either way. Thank you, Brianna, for checking in. Appreciate that. Let's do some cross multiplication. We want to get x by itself, and cross multiplying is a nice, quick, easy way to do that. So we take the top on one side and we multiply it by the bottom on the other side. So I'm going to have 32. I'm just going to lose all the gas and everything else I wrote. 32 times x is equal to, and I'm going to go top on the other side times the bottom. And I'm going to get 8 liters of gas times 1. So I end up with 32x is 8. And then I need to get x by itself. So I'm multiplying x by 32. The opposite of multiplying by 32 is dividing by 32. So I end up with x is 8 over 32. Now, if I were to tell somebody, oh, you just need to add 8 over 32 to the old gas can, they would say, what are you talking about? You've lost your mind. 8 over 32, what does that even mean? So we need to get it in a decimal. So we jump over to our calculator. See if I can find a calculator. Press menu. Okay. I'm going to go 8 divided by 32, and I get 0.25. So this is 0.25, and when I first started the question, I knew that everything was in liters. So this is 0.25 liters. If I want to convert liters to milliliters, I know that there are 1,000 milliliters in 1 liter. So I'm going to multiply this by 1,000. Jump back to my calculator, just go times 1,000, and I end up with 250 milliliters. So that's how much oil I would have to add to 8 liters of gas. Now, I know this sounds kind of funny, but I do these calculations all the time in my garage. I've said this before. You get 10-liter jerry can, 50 to 1, or I have I forget how big my gas tank for my boat is, but it's like a 25-liter tank. It's actually in gallons because it's older than I am, and then you got to mix in oil. So literally, this calculation is something I do a lot of times in math. It's like, when am I ever going to use this, Mr. Borden? When you go fishing, you're going to need to know how to do this calculation if you have an old 2-stroke motor. Or when you mow your lawn, you got a whipper snip or a chainsaw, if you're cutting up some firewood. Literally, you'll use this calculation to do that. Let's see if we can do this one real quick. This second one was a mixture of 40 to 1. So 40 parts gas for 1 part oil. And I had 20 liters of gas, and I need to figure out how much oil I'm going to add there. I'm going to do the exact same process. Top on one side, bottom on the other side. So I'm going to get 40 times x is 20 times 1, or just 20. Divide both sides by 40. I'm going to get x is 20 over 40 is the same thing as a half, or 2 over 4, or 20 and 40, 0.5. And then I'm going to times it by 1,000, so I get x is 250, 0.5 times 1,000, 500 milliliters. There you go. So there's 15. Did anybody have any further questions from the learning guide that you wanted me to go through? I'd be happy to do that. If not, I would just like to continue on with this learning guide. Okay. If something does come up as I'm going through it, obviously just let me know, but there we go. So I asked you guys to stop at the bottom of page 3. There is letter C, which is the exact same as the previous ones we did. I'll get it set up for you. You have 16 to 1, and then you have 50 liters over some amount of oil. So you need to solve for x, figure out what x is. Cross multiply. All right, so this is a similar type question. We're still talking about Mike. This is on page 4 now, top of page 4. Mike, instead of talking about how much gas we have, now we're talking about oil. So he has 15 milliliters of oil left. What ratio would he use to determine how much gas he would need to mix with the oil for a 16:1 ratio? So let's maybe just set this up. There's a bunch of kind of things to help us get through it. It's kind of like which one's the right one. So 16 parts gas to 1 oil. And then when we write these ratios, remember whatever's on the top needs to be gas. But in this question, this is kind of, think of this as like multiple choice. It doesn't do a very good job of describing it. So which one's right, A, B, C, or D? So I know it's a 16:1 ratio, 16 parts gas, 1 part oil. And then he says you have 15 milliliters of oil. But I have 16 gas, and now it's saying 15 gas. The top's the gas, but this should be really oil. So that's a problem. This 15 is referring to oil, so I don't like this one. So we get rid of A. No good. All right, B was 16 parts gas to 1 part oil. And then I have how much gas, and then this is oil. That one's looking pretty good. So 15 is the oil. Again, on the top here, the top is representing gas, but this 15 is oil, so I don't want that. I want gas on the top on both. And then this last one looks okay as well. So this is gas, oil, and then I have how much gas do I need for 15. So the decimals are different here, right, in the bottom. So what I'm thinking is this 15 on the bottom is just milliliters, and then this 15 is in liters, because 15 milliliters is equal to 0.015 liters. That's the conversion from milliliters to liters. So both B and D will work. This one will get you an answer in milliliters. This one will give you an answer in liters. So it doesn't really matter. Obviously, we can convert back and forth from those. So there you go. So letter B says, explain why the others are not correct. We said we need gas to be on top. Or if we're talking fancy math, in the numerator. And remember, numerator is the top of a fraction, denominator is the bottom. So the ratios didn't work because they were mixed up for A and C. No go. But B and D both looked okay. One was for milliliters, one was for liters. I guess we should finish this question off. Letter C asks, how much gas would Mike need to mix with the 15 milliliters of oil? I'm gonna use D because I have a feeling, well, it won't be that much gas to go, but I like dealing with everything in liters because that's gonna make sense. So I'm just gonna bring down what we did up here. So we had 16 parts of gas to 1 part oil was equal to some amount of gas, I don't know, and then I have 0.015 liters of oil. That works out. Cross multiply. I'm going to go 16 times 0.015, and then I'm going to have 1 times x, or just x. I could leave it as that. This one's kind of nice. I get it all done in kind of one step. I don't have to divide because x is by itself. So what I'm going to do is I'm just going to do the multiplication. 16 times 0.015, and I get 0.24 liters of gas to mix with that 15 milliliters of oil. It probably would have made sense to do the calculation in milliliters because 0.24 is so small, but oh well. I'm happy with that. All right, are we kind of okay with those type of questions? So up to this point, it's all kind of like mixing gas and oil together. The next stuff is the same sort of ratio things, but just dealing with sort of different word problems. So John lives in Calgary, builds raised gardens or window boxes. He finds that the best ratio is 5 to 3.5. So that means a box that's 5 feet long would be 3.5 feet wide. So the ratio kind of can be extended. If the box was, 10 feet long, then it would be 7 feet wide. You just double it. So what's the largest box he's built had a width of 14 feet. How long was it? All right. Let's write down our ratio as a fraction to begin with. So we had 5 to 3.5. So this is 5 long to 3.5 wide. So instead of writing it with a colon in there, we're going to write it as a fraction. Now, remember, when we deal with these, we have to have the same units on the top and the same units on the bottom. So the question says it had a width of 14 feet. I don't want to put that on the top because we've decided that everything on the top is actually going to be length. So the width needs to go on the bottom. And it says how long was the box. So I don't know how long it is, so I'll give that the letter X, and I'm going to put 14 on the bottom. Because this is 14 feet wide. Now, to solve for x, it's the exact same as all the ones we've done previously. We're going to cross multiply. I'm going to take the top on this side, multiply it by the bottom. So I'm going to get 5 times 14, and then I'm going to take the top on the other side and multiply by the bottom. I'm going to get this x, which I'm going to solve for, times 3.5. Now I'm multiplying the x by 3.5. If I want to get it by itself, which is the whole point of the question, I'm going to have to do the opposite. I'm going to have to divide by 3.5. All right, so 5 times 14 divided by 3.5. 5 times 14 is 70 divided by 3.5. Should be 20, and it is. So I get 20 is equal to x. So what does that mean? Well, if the box is 14 feet wide, it must be 20 feet long. All right, so that's 17. I'm going to leave you guys with 18. It's the try these. A, B, and C. 3 parts there. So that's page 4. I think you guys can do that. And we'll jump to 19. These questions, number 19 and 20 and the rest of this, next basically page and a bit, these questions are tricky at first, but as soon as you see how they're done, you'll see that they're all completely the same, and it's pretty straightforward. And for some of you, kind of organizing your work in a table is going to just seem like a big waste of time and a lot of work, but it makes these questions so much easier. So when you do these types of questions where you have kind of multiple ratios happening at the same time, it's a really good idea. I'm going to insist that you draw a table, and it'll just organize everything, and it makes calculating the answers really easy as well. Because if you don't draw a table to kind of organize things, you can get lost in the question. There's so many numbers, there's this part, that part, that part. It's really confusing. So let's read through it. One of the most popular blends of juice is orange, pineapple, mango. The ratio is 5 parts orange to 3 pineapple to 2 mango. The ratio is 5 to 3 to 2. A container of juice is 1.5 liters. How much of each juice would be in every container? So it's looking for like the volume of juice there. So the very first step that you need to do for all of these types of questions, it's just kind of think of it as a group of questions where you have multiple ratios. It's not always going to be juice. Sometimes it'll be something else. The next one is making some concrete. You need to find out the total, how much you have in total. So if you had 3 parts of pineapple, 2 parts of mango, and 5 parts orange, how much do you have in total? So the total units is going to be 5 orange plus 3 pineapple plus 2 mango is going to be 10 parts, which is nice. 10 is a nice number to deal with. All right, so once we've kind of established that there's 10 parts altogether, I had 5 parts of one, 3 parts of the other, 2 parts of the next, there's 10 parts. We need to figure out how much each juice kind of makes up of the total 10. So if I was just looking at the orange juice, it says that 5 parts of the juice are orange, and I know in total there are 10 parts. So 5 out of 10 are orange. Pineapple, I had 3 parts pineapple and 10 in total, so 3 out of 10 are pineapple. And mango, I started with 2 parts of mango and I had 10 parts total. So 5 out of 10 is orange, 3 out of 10 is pineapple, and 2 out of 10 is mango. So recall from before, we can write a fraction as a ratio. So 5 to 10 is going to be the ratio there. 3 to 10 is going to be the ratio for pineapple. And 2 to 10 is going to be the ratio for mango. Then we can talk about percents. So if I said you got 5 out of 10 on a test, some of you would be like, yeah, 5 out of 10, nice. And others would be devastated. 5 out of 10, you just go 5 divided by 10, you get 0.5 or 50%. So I can go 5 divided by 10 is 0.5, which is 50%. I can do the same thing for pineapple. I had 3 out of 10, which is 0.3, which is 30%. And then I have 2 out of 10, which is 0.2, which is 20%. Okay, the last thing we need to do is figure out how much volume of each of these things. So far we've talked about the ratio. So, like 5 parts of orange juice for every 3 and 2. Now we've talked about the percentage. Half of that juice is orange, but we don't know the volume. Because the container is at 1.5 liters, we need to know how much kind of volume of orange juice we need to add to make up this juice. So in order to do that, what we're going to do is we're going to take the percentage, and we need, so I should stick with red here, we need 50% of 1.5 liters. So basically half of 1.5. So I can do this a couple ways. I can go, so 50% is 0.5 as a decimal times 1.5 gives me 0.75. I can think of it that way. 50% of 1.5. And then I'm going to go 30% or 0.3 times 1.5 liters. What does that give us? 0.3 is 30% times 1.5 liters, 0.45. And then this last one is going to be 20%, so 0.2 times 1.5 liters. .2 times 1.5 is 0.3. liters. And this part C is the total blend. So I think this is just having us check our answer. I have 0.75 liters plus 0.45 liters plus 0.3 liters. Altogether gives me 1.5 liters. So it's all there and accounted for. All right, in chat, how do we feel about that? We kind of like, yeah, no, meh, and a sideways thumb. We got this under control. Seems pretty straightforward. I'm lost. Give me a thumbs up, thumbs down, smiley face, sad face, confused face. I got a thumbs up. Meh. Fair enough. It's the first one you've seen. Wouldn't expect you to be a pro right from the beginning. Another thumbs up. 3 people are with me. Yeah, Brianna, thank you. Emery and Costin are on the fence still. That's okay. We'll look at a few more. Nobody should cry over math, Costin. It's not worth it. All right. I'm going to leave 20 and 21 to you guys to do for next day. They are exactly the same as what we've just done. I will encourage you to draw the little table. So you have, in this first one, you're going to have gravel. You're going to have water. And you're going to have cement. You're going to include the ratio. You're going to have percent. And you're going to have volume. So that's what your little chart's going to look like. And it's just a really easy way to kind of organize these questions. That should get you on the right track. 21 is going to be the exact same process. You're going to have flour, you're going to have regular flour, cake flour, and sugar. Flour and cake flour, those are different things. Who knew? Clearly I don't spend enough time making cakes. All right, example number 22. Jennifer, Brad, Robert, kayaking on the west coast of British Columbia. 7 to 10 days, meals are split into breakfast, lunch, and dinner. Jennifer is organizing pancakes and must pre-mix most of the dry ingredients. 4 parts flour, 3 parts oatmeal, 1 part spelt flour, 1 part oat bran. She makes mixture a total of 12 cups. How much of each ingredient is required? Use any of the 3 methods shown. All right, let's see if we can sort this out. So let's start with the total. It's going to be difficult for me to do this, not being able to see it all at once. See what I can do here. So whole wheat flour, we'll call it WW flour. We have 4. We have 3 oat. We have 1 spelt. I'm learning about all new kinds of flour today, if nothing else. And 1 part oat bran. I'll just call it bran so I don't get too confused. So what is the total I'm dealing with here? I have 4, 3, 1, and 1. So I'm just going to add these together. So I'm going to have 4 plus 3 plus 1 plus 1. It's going to give me 9 parts. 9 parts total. All right, let's look at this whole wheat flour. We have WW, we got some oat, we got some spelt, and we have some bran. Sounds like some pretty healthy stuff. Let's figure out the ratio for each of these. So the whole wheat flour, I had 4 parts, and then 9 in total, so 4 out of 9. There's kind of no way I fit this in here. The oat, my ratio was 3 parts out of 9. My spelt was 1 part of 9, and my bran, again, was 1 part of 9. So the next column, we'll figure out the percent. 4 out of 9, so I could draw some lines here to kind of... Four divided by 9 is 44. So the bran, whatever we're calling this stuff, oatmeal, is 44% whole wheat flour. 3 out of 9 is a third, so 30% of it is going to be oats. 1 out of 9 is 11% for spelt. And again, 1 out of 9 is 11% for bran. So we've kind of done each of those percents. It tells us that there's 12 cups in total. We need to figure out that 12 cups, 44% of it is this whole wheat flour. So what we're going to do is the same thing we did before. 0.44 times 12 cups, because that's our total. We're going to go 0.3 times 12 cups. We're going to go 0.11 times 12 cups. And then we're going to go 0.11 times 12 cups. So let's do the math here. 0.44 times 12. That's 5.28. So 5.28 cups of whole wheat. 0.3 times 12 is 3.6 cups of oats. And the last two are going to be the same. So 0.11 times 12, 1.32. So there you go. How do I get the percent? I took the total, which was 12, and I know that I have each of the percents. Oh, how did I get the percent in the first place? I see what you're saying, Costin. The percent is, so let's think about the question again. I had this 4 parts flour, 3 parts oat, 1 part spelt, and 1 part bran. That was all just given to me in the question. So together, I had 4 of something, I had another 3 of something, I had another 1 of something, and another 1 of something. So in total, there was 9 parts of stuff. 4, 3, 1, and 1. 4 and 3 is 7. Another 1 is 8. Another 1 is 9. So I had 9 things in total. Now, originally, 4 parts was whole wheat flour. So all you need to do is just say, okay, I started with 4 parts of whole wheat flour and divided by 9. So I went 4 divided by 9, and I got 0.44444. If I times it by 100, I get a percent, so 44%. And then I did the same thing again. 3 divided by 9. Well, 3 over 9 is a third, so that's 30%. And then 1 over 9 and 1 over 9 was 11 and 11. So I took the fraction of each of the ingredients and divided it by the total, and that's how I got with those percentages. And then to get from the percent to the cups, I took the percent and multiplied it by the total amount of cups. All right, example, Jim's having 5 friends over for dinner. He needs 120 or 150 grams per person, 6 people including himself. What's the total grams of prawns Jim needs to buy, and how much will it cost him? I'm thinking you guys could probably work through this on your own. You don't need to even set it really up in a table or anything. It's pretty straightforward, I think. And so just take a stab at it. I'm not going to put up a timer or anything, but I'll just give you like a minute to just kind of think through it. You're gonna try 23 on your own, and then 24 we'll do right now. But just try to set it up, see how you do, and see if you get to the right place. All right, so each person needs 150 grams. There's 6 people in total. So I'm going to go 6 people times 150 grams. And that is going to get me 900 grams of shrimp in total is how much we're going to need. Now, each 100 grams cost $4.95. So this is kind of like the fuel questions we were doing before. We're going to have $4.95 per 100 grams. So this is a rate. It'd be like 4 liters of milk for $5. We just have $4.95 per 100 grams. We're going to make this equal to, I know that I have 900, I need 900 grams in total, and I'm trying to figure out how much that's going to cost. So notice I have grams and grams on the bottom, I have dollars and dollars on the top. Exactly the same as the fuel questions, except we're dealing, instead of a fuel ratio, we're dealing a cost divided by a mass, or a weight, I suppose. This is just exactly the same as what we've been doing. We're just going to cross multiply and solve. So I guess we'll start here. 495 times 900. It's going to be equal to x times 100 I need to get x by itself. The opposite of multiplying by 100 is dividing by 100. If I do it to one side, I have to do it to both. 100 divided by 100 gives me 1, so I'm left with just x over here. And on the left side, I have 4.95 times 900 divided by 100. So let's do that on our calculator. 4.95 times 900 equals, and then divided by 100 is $44.55, or 44.55. Now I was looking for cost in dollars, so I will write a dollar sign out front. So there you go. You probably could have just worked that one kind of out in your head without, not like the math, but just kind of setting it up, because you're like, okay, there's 6 people, 150 grams per person. So you have the 900 grams total. Then you just take, okay, 100 grams cost $4.95. You could just do that 9 times sort of thing. $4.95 9 times. So really that's all we did, was multiplied $4.95 times 9 to end up where we did. The next one, 25, is a little bit different because it says it's discounted by 25%. So you're going to do the exact same thing as you did up above. It's going to look almost identical. When you get your final price, you're going to have to take a quarter of it away. That's this 25% discount. So maybe I'll just do this one, because we haven't talked about discounts or anything yet. So there's 8 people. This looks exactly the same as above. Sorry, not quite exactly the same. 8 people times 150 grams. 8 times 150 is going to be an extra 300, 1,200. Let's make sure of that. 8 times 150. 1,200. So 1,200 grams total, and the cost is the same, so it's 4.95 per 100 grams is equal to the cost, X dollars divided by 1,200 grams. I cross multiply 495 times 1,200. So I get 495 times 1,200 is equal to X times 100. Divide both sides by 100 to cancel out. If I do it to one, I have to do it to the other. And I get 495 times 1,200 divided by 100. So I get $59.40 before the discount. All right, so I went kind of quickly through that because it's exactly the same as up above. And I'm just going to slide over a little bit here. So we have $59.40 before our discount. So we need a 25% discount. That means we need to take 25% away. So we need to first figure out what 25% of $59.40 is. 25% as a decimal is 0.25. 0.25. So we're going to go 0.25. We're going to multiply it by $59.40 to figure out what our discount is. So 59.40 times 0.25. This gives us $14.85. So our discount is $14.85. So it doesn't ask for the discount, it asks for how much it'll cost. So if the cost was $59.40, I say, 25% discount, it's going to be $14.85. You're going to go $59.40 minus $14.85. And you get $44.55 total. So you should be able to figure out what kind of percents of numbers are and things like that. They do come up a lot, especially in this unit when we start talking about discounts. So there you have it. I would like to see how many more. Maybe we'll just do one more. Just kind of looking ahead here. I'll do one more question, and then that's kind of it for the first lesson in Unit 1. Everything from this next one on is kind of stuff you've seen before, or kind of similar questions, just kind of reworded a little bit differently. So I want you guys to try 26. I'll do 27 for you because it introduces a bit of a new idea. So at a track meet in Edmonton, the women's 1,500 meter race was won in a time of 3 minutes 56 seconds. Speed is calculated in meters per second. What is the average speed of the woman who won the race in 3 minutes and 56 seconds? They don't really tell you this, but in order to find average speed, you are going to take the total distance and divide it by the total time. Good news for you guys is that this question is, you could be taken straight out of Science 10. So the foundations, the other math group, they won't see any of this stuff, and it'll be new to them when we get to it in Science 10. But for you guys, this type of question shows up again in Science 10. The whole physics unit in Science 10 is based on average speed and velocity and acceleration. So if you guys kind of understand this stuff a bit now, when you encounter it again at the end of the year, which seems like a long ways away, and it is, about 8 months from now, we're going to cover this exact same stuff again, which is kind of nice, a little bit of overlap there. So what we need to do is figure out how far she ran and how long it took her. The problem is that time isn't something we can just write as a decimal. If you kind of get what I'm saying, it's 3 minutes, 56 seconds. It's kind of like feet and inches. It's time is a base 60 system, and inches are base 12, going from feet to inches. So it doesn't work. We can't just write 3.56 because if you think about, if I said 3.5 minutes, you'd think, okay, that's 3 minutes and 30 seconds. But in this case, 3.56 doesn't work because it's 3 minutes and 56 seconds. Like that 56 is almost a whole nother minute. So we can't just go 3.56. So the first thing we need to do is convert our time into just seconds. So let's do that. So we had 3 minutes times 60 seconds per minute. It's going to give us 180 seconds. And then we're going to add to that the additional 56 seconds. So we're going to have 180 plus 56 seconds. So that's going to give us 236 seconds. So time doesn't kind of work out nicely. It turns out that 3 minutes and 60 seconds is 236 seconds. How far did this person run? Well, it's a 1,500 meter race. So I'm thinking the total distance is going to be 1,500 meters. And the total time is going to be 236 seconds. She ran 1,500 meters in 236 seconds. So let's just plug that information in. 1,500 meters divided by 236 seconds. Now in the question it says speed is calculated in meters per second. We have meters on the top, seconds on the bottom, so that's going to work out. So 1,500 divided by 236 gives us 6.355. We'll call it 6.36 meters per second was her speed. So this average speed type calculation is going to come up a lot from time to time. That's something you should just know. Speed is the amount of distance you've covered in an amount of time. Just think about if you're in a car going 100 kilometers per hour. Well, what does kilometers per hour mean? Well, the kilometers is the distance and the hours is the time. So we can measure something in kilometers per hour, we can measure in meters per second. It's a distance divided by time. 100 kilometers means if I was traveling 100 kilometers an hour, every hour I'm traveling 100 kilometers. If I'm traveling 6.36 meters per second, that means that every second I'm traveling 6.36 meters. That's just kind of how that works out. So I'm going to just pause there, just kind of looking ahead. So the majority of the remaining questions are ones that you'll be able to do given the questions we've already done. So number 28 is more meters per second stuff, 29 is the same. And then 30, 31, 32, 33, 34, 35 are all questions that are like using the techniques we used up above. So unit pricing is where we're going to leave off till next class. And I won't see you guys again until Tuesday next week at 10:30. So, or 10:20, I don't know. We'll check the schedule. 10 something next week, Tuesday. So there you go. You guys should be able to finish up to question 35, which is all of Unit 1, Lesson 1. So if I just jump to the course, I wonder if I'm still logged in. No. Just give me a second to log in. Squat down here. Yes, I got it. All right. So what have we done so far? We are just on this lesson 1 still, and we've kind of broken it into 2 days. So we did ratios, rates, and then we did a little bit of proportion stuff. So we're going to have lesson 2, lesson 3, and lesson 4. These lessons are really long. There's lots of questions in them, so I know we're not going terribly quickly through this. I did want to remind you as well that not next week, but the following week is the math midterm, which you guys are going to come in to write on November 3rd. It's a Thursday. So I'm going to do my best to finish up Unit 1 for next Thursday. That means we'll be done Unit 1 and 3. And I would, Units 1 and 3 will be on the math midterm. So just 2 units. It'll be a test that takes about an hour, not terribly long. Nothing tricky or challenging or difficult on it, just kind of questions you guys have seen already. So just kind of give you a little heads up on that. That's 2 weeks away. It'll be Thursday, November 3rd. Test, you guys will come into McWilliams Center, write it on Units 1 and Unit 3, the 2 we've done so far. One way or another, we're finishing up Unit 1 before the 3rd. So that gives us 2 classes next week and 2 classes the following week. So that should be good. 1, 2, 1, 2. Yeah, we'll have to finish one of these units in one day. We'll figure it out. So there you guys go. Does anybody have any questions before I leave you there? Of course, there's no field trip this Friday. We are at professional development, and then you guys will have fencing after this. And last year, the students had a lot of fun fencing. So if you never tried it before, which nobody has, because who fences in their free time, come on out. It'll be good. You're going to finish up to the bottom of page 8, essentially, everything up to unit pricing. That's what we'll pick up next day. So have a great weekend, guys. If you haven't finished the Unit 3 learning guide and test, you need to get that done ASAP. I won't be at my desk tomorrow. I'll be out at the university. So if you submit the learning guide by the end of the day today, that would mean I can get that password out to you. If you submit it on Friday, I won't get it and get the password to you till probably end of the day Monday. So if you wanted to do that test over the weekend, you need to have it done. Unit 3 stuff submitted by the end of the day today. Unfortunately, I will be without computer tomorrow. So have a good weekend, guys, and we'll see you next week. Bye-bye.